Hello everybody, this is Dr. Nurbad Shah. Today video is about use of calculator in multi-step methods for solution of differential equation. Okay, we usually call them predictor-corrector methods as well, and you must know that these methods are not self-starting. Usually RK methods or Euler method, they simply use the initial condition and then we find the first value for the solution, that is y1, then we find the next one which is y2 and then y3 and so on. These methods, they cannot be started with y naught only, that's the initial condition. You need to know some more values as well. You should know at least 3 values or at least 4 values including initial condition. Otherwise, in other words, we say that you would know 3 values other than initial condition. Okay, so you see that to start to apply these methods, we need to know x naught, y naught, which usually come from the initial condition x1 y1, x2 y2, x3 y3. They might be found by using RK method, they might be found by using Taylor series method, Picard's method. You can use Euler method as well. Okay, so these methods, the predictor-corrector methods or multi-step methods, can be used for generating y4 and onwards. Okay, we can use these methods to find y4. Okay, so we'll be having 2 formulas in this case. The one formula will be computing predicted value of y4, and that formula usually known as predictor formula. And once we updated the value of y4 or y5 and so on by using predictor formula, we use that predicted value of y4 and use another formula which is known as corrector formula to improve the value of y4. Okay. The first method we will be talking about, that is Milne Simpson predictor-corrector method. In this method, what do? We are solving a differential equation of the form y dash, which is equal to f of x y, with some condition, obviously, that is y of x naught is equal to y naught. y1, y2, y3 can be found by using any of the methods, single step methods. Okay. Now how do we derive predicted formula for this specific method? We use Newton-Fowler method, because you see, if you solve this equation y dash, which could be written as dy by dx, and then we multiply dx on the right side, integrating both sides. So we replace basically what? We replace this f with its interpolating approximation, and then we integrate this function with respect to p. Okay. If I write this for you, that's a simply, see, I could write this equation as dy equals simply this is f into dx, where f is obviously depending on x and y both, and then we integrate this from y naught to y4, because we are interested to find y4, and obviously we are integrating this one from x naught to x4. Okay, so using these x4, sorry, and then we do what? We simply replace this f by the interpolating polynomial. We use Newton-Fowler difference formula, and we'll be having 5 points, so the polynomial will be taken up to degree 4, and then we integrate this. Okay, so that's why we are using fp as f naught plus p del f naught plus p square minus p to del square f naught, and integrating that from where to where. When you convert all these integrals from dx to dp, the limits will be converted from 0 to 4, and this will give you, this integration will simply give you y4 minus y naught. So for predictor formula, we are basically taking integration from y naught to y4 and then x naught to x4. Okay, so how do we do that? Let's say we want to find this integral now, integral from x naught to x4, f of x y dx, where f will be replaced with that interpolation formula fp, and the limits will change from 0 to 4, and you must remember dx, which can be written as h times dp. Okay, and then you simply replace this fp with this quantity. Okay, and then integration with respect to p and putting limits from 0 to 4, that will give you 3 times f naught, and then we have 6 del f naught plus 5 del square f naught, and so on, which could be further simplified to get this quantity is from x naught to x4, which will give you 4h by 3 into t f1 put del f naught del square f naught del cube f naught, putting the values of all these quantities, and then after some manipulations we get this quantity 4h by 3 2f1 minus f2 plus 2f3. Now, as I explained earlier, when you integrate left side dy from y naught to y4, and then you simplify that, we get what? We get the predictor formula like y4 equals y naught plus x naught to x4 f of x y dx. So, we have x y naught plus 4h by 3 into 2f1 minus f2 plus 2f3 from here. Okay. And this could be generalized if you want to find y5. So, it will be simple written as y1 equals y1 plus 4h by 3 2f2 minus f3 plus 2f4, and so on. The same thing can be done for y6, y7, y8, and so on. So, more generally we can have the formula is yn plus 1, that is yn minus 3 plus 4h by 3 2fn minus 2 minus fn minus 1 plus 2fn, where n starts from 3 because we want to find y4 first. So, if you put n equal to 3 here, you get y4. This will give you y naught, this will give you y1, f1, f2, and f3 then, if you put n equal to 3. If you put n equal to 4, obviously you'll be getting y5, this will be y1, and so on. So, you can use this formula for prediction of y4, y5, and onward. Where you want to stop. To derive the corrector formula, what do? We use that Simpson concept. So, in Simpson, if you remember, we have taken integral from x naught to x2 instead of x naught to x4, and then we could prove in similar way that integral from 0 to 2 fp dp, that could be written as h by 3 f naught plus 4 f1 plus f2, and then the corrector formula will become what? It is y2, that is equal to y naught plus this one, because in this case what do? If you see, we have a y dy that was equal to f dx, and we integrate this from y naught to y2, and the same thing on the right side, we integrate that from x naught to x2, and then we simplify this one. Left side give you what? That will simply give you y2 minus y naught, whereas the right side will give you simply h, and integrating all these things we get h by 3, which is Simpson concept. So, h by 3 we get f naught plus 4 times f1 plus f2, okay, and then we simply take this y naught to the right side to give this one as y2 is equal to y naught plus h by 3, and so on. The same thing can be extended towards y2 to y4. This will become x2 to x4, and then we simplify this, it will give you y4 will be y2 plus h by 3, and so on. It will become y2, this will become f2 plus 4 times f3 plus f4. Okay, and then you can generalize that in for y6, and then you can go for y5 as well, y6 as well, and so on. So, the same thing can be done as I said here, explain that y2 plus h by 3 f2 plus 4 f3 plus 4 f4, and then from here we could generalize this rule as yn plus 1 equals yn minus 1. Now, in previous case it was yn minus 3, but now it is yn minus 1 plus h by 3 fn minus 1 plus 4 fn plus fn plus 1. Keeping in mind that this fn plus 1 is what? That's the implicit part now, because this fn plus 1 will be equal to what? and that is f of xn plus 1, and this is yn plus 1, which is obtained from the predicted part. This is basically the predicted value. Okay, keeping this in mind, that we'll be using the predicted value here in fn plus 1. Okay, again for n equal to, we'll starting from n equal to 3. So if you put n equal to 3 here, you get y4, this will be y2, this will be f2, this is f3, and this will be f4, where f4 will be obviously f of x4 y4, predicted value. Okay, keeping in mind this thing. Okay, so let me do the example for solution of this differential equation. Y dash is equal to x minus y with the initial condition y of 0 is equal to 1. Okay, and the starting value are basically obtained by using RK4 method, and they are given obviously for x equal to 0 it is 1, that's the initial condition. When we have x equal to 0.1, so we have 0.9097, this is 0.8375, and this is 0.7816, right? So in formula, for predicted formula, obviously you know that we are having we are using f0, f1, f2 and f3. So in this case, if you see, the function is what, that is x minus y. So we have f is equal to x minus y, this is 0 minus 1, this is 0.1 because this is x1 minus y1. So we have 0.1 minus 0.9097, which will give it this one, 0.2 minus this one. So we have these values, okay, and we're going to use these values in the predictor formula first, and then we will find what we will be finding corrector. We will be updating the y4 or y of 0.4 by using corrector formula. Now the question is, can we do this by using calculator? I hope you could find these values very easily, so we don't need to find these values by using calculator. Or if you use calculator, so we don't basically iterate them. I will be using these values directly as an input. Okay, so we may label them as, I would call this one as A. So keep this in mind, I will be calling this one as A in calculator. I'll be calling this one as B, I'll be calling this one as C, and then D. Okay, so I think we don't need in f0 anywhere in the formula, so I may not call this one A, I may call this one as A, right, because we are not using f0 anywhere, if you remember from the formula. And we would be calling this one as B, I'll be calling this one as C. Okay, I may be calling M, I'll be using M for my H, which is in this case 0.1. Okay, I'll be using X for X and Y for Y wherever I need. Okay, I think these are something I'll be using in calculator. So keep these in mind. A means f1, and then B means f2, and C would mean f3. Okay, so what would we do? So we need to find the predicted value at n equal to 3. So that is y4 equals y0 plus 4h by 3, 2f1 minus f2 plus 2f3. Okay, so you see, we are not using f0 anywhere, we are using f1, f2, f3. So as I said, I'll call this one as my f1 as A, this is my B, this is my C, and H is taken as M. I'll be using y0 to be my simply Y. But in one step I'll be using y0, and the other step I'll be using the value y2. Okay, putting the values, so you see that y4 equals y.54. This is 1 because my y0 is 1, and plus 4 into 0.1 because h is 0.1, and then putting the values of f1, f2 and f3 to get this value. This is 0.7407. Then we go for the corrector formula. Corrector formula is what? y4 equals y2 plus h by 3, f2 plus 4f3 plus f4. Okay, now you need to understand this. See, f4 is what? That's the f of x4 y4, where y4 is the predicted value which is obtained here. and then I'll find f4, which is x4 minus y4. x4 is 0.4, y4 is this one, so we get minus 0.347. Now how do I do this in calculator? So you see, I'll be simply putting this value I'll be replacing this value with a, right, because you see that we are having f2 here, we are having f2 here, we are having f3 here, we still use f3 here. I'm introducing f4, but y1 is gone, so I'll be doing what? I'll be simply replacing that a for f4, right, because I don't want to use this f1 again. Okay, and second thing, I'll be using the same formula. Okay, I'll be using 4h by 3, so you see that I'll be replacing m with m by 4. Just to get h by 3 or m by 3, if I replace m with m by 4, the 4 will cancel, I'll get h by 3. I want to have f2 back with positive sign, so I'll be replacing b with the minus b. Okay, I'll be using f3 here. You say we are having 4f3, but we have used 2f3, so I'll be simply replacing c with 2c. Okay, and f4 is already there, which is a. It was 2f1 2a, but I'm going to use what? I'm going to use now f4 as a, so it will be taken as f4 divided by 2. If you want to use the same formula again and again, if you want to use this formula again, so you can input this formula and this formula, and because of the space issue you may find yourself in trouble. Okay, so putting these values, I'm going to explain that in a while using calculator, and you see the value is same, 0.7407, 0.7407. If the predicted value and corrected value are same, we will stop the iteration here up to certain number of decimal places. If this value was different from here, then you would repeat the corrector formula only. You don't need to repeat the predictor formula. You'll be simply replacing again this f4 by finding this x4 minus y4, but now this y4 will not be the predicted one, it will be the last corrected one. And if these two corrected values are repeating, you will stop the process, otherwise you will apply the predicted formula again. Okay, so you see in this case they are basically repeated, so we are 0.7407, 0.7407, the values are repeated, it means we can stop these iterations. Okay, now how do we do that? By using a calculator. Let me explain that for you. So again, as I said in last videos, that the mode of calculator must be in math mode, so you see that this is in math mode. So I'll simply write this formula first. I'll say y equals y again, but keep one thing in mind, that I'm going to use input the value of y differently, because in case of predictor formula we are having y naught here, whereas in case of corrector formula we will be using y2 here, because in corrector formula we are having for y2 here. Okay, so keeping this thing in mind, so it's y naught. I'll just replace y plus, then I'll write 4h by 3, so we have 4 multiplied by m. I said earlier I'm going to use m for my h, and then we have divided by 3, and then we go to the brackets. So I'll take simply 2 times my a, because I called f1 to be a, so 2 times a minus b, because we called f2 to be our b, so it's minus f2 plus 2 times again I go for c, because we called f3 to be c, and then we simply close the bracket. After that, what would I do? I'll simply find this value, which is my a again. Okay, so I'll be simply taking a back, because you see in the formula we will be basically throwing f1 from the predictor formula to get the corrector one, and we are introducing f4 here. So I'll use the same formula. I'm not introducing a new formula. Okay, you can do that as well, just because you will be simply finding this f4 for x4 and y4, and then you will be finding this predictor. Because I want to repeat the formula again and again, maybe we need some time that, so that's why I'm using this formula again and again. So this is my formula. Now what would I do? I'll simply find this f4, which as I said, I'll call it a back. So my a is equal to what? The a will be simply x minus y, where this y is now my predicted value. Okay, but what would I do? I will simply divide this by 2 as well, because here I am using f4. Here in the formula it was used as 2f1. So if I use this formula, I'm going to make it only f4. So dividing that quantity by 2. So we may divide this one by 2. And just divide this by 2. Okay, right. You can divide that when you are asked for the values as well. Okay, let's calculate that. It asks for the initial value of y, where the initial value of y is 1, because we are using y naught, keeping in mind. So I'll just give it 1. Okay, and then it asks for m. So m is what? That is 0.1. Okay, so I presume I am doing okay. It will ask for a now. So my a is what? That is minus 0.8093, minus 0.8093. This is my f naught, f1, sorry. Okay, so I just called that a. Pressing equal, then it asks for b. So my b is minus 0.6375. Okay, sorry, I just written incorrectly. 0.6375. And then it will be asking for c. So the c is what? It is minus 0.4816. 4816. Okay, now it asks for x as well for this formula, and we know x is what? That was x was 0.4. So just give it 0.4. Then we press equal. You see that we get 0.7407 up to 4 dp. It is okay. Now you see, I have to apply the corrector formula now. First, when I press equal, it will give us this value, which is this one. Okay, it's already divided by 2, keeping in mind. If you multiply this value with 2, you'll be getting this one. Okay, so we have divided by 2, so we get minus 0.1703, because we're going to use the same formula back. So yeah, this is divided by 2 in this case, because I am using f4 and f1 interchangeably. So I'll dividing that by what? By this one. Okay, pressing equal. You don't need to change this value, because we are using simply no, we need to give this initial value now to be y2, and in this case y2 was this value, which is now y2 is what? This is y naught, this is y1, this is y2. So we'll be taking this value 0.8375 here. Okay, so this value will be replaced. Yeah, keep this in mind. Okay, 0.8375, because in corrector formula we are having y2. If it was y4, then I might have used this y again, same value, but we are having y2 now. So pressing equal, then we have m. Now m is what you see in the formula. We are having 4h by 3 here, whereas in this case we are having formula to be what, that is h by 3. So it means I'll be dividing m with what, I'll simple write this my m, but I'm dividing m with 4. Because we are having 4 here in the previous formula, but now I am having h by 3. Keeping in mind I am using this formula for character as well by introducing something a bit some values. So m divided by 4, I'll be using this one. Now a is what, a is already found, that was divided by 2. b is will be fixed, c is fixed, and d x is 0.4. so you see that we are getting something is wrong. Where did I make a mistake? Oh, sorry. We should have divided this value by by this thing as well. So let me do that again. So it is done now. Okay, so I'll be taking y back to be 0.8375. 0.8375. This is my y. M is already done because it was as I said, you have to divide this by h by 3. We may take this 0.1 by 3. It was divided already 4h by 3, so we don't need to divide that again. So that is equal. Now what about a? A is obviously this quantity, but we will be dividing this by 2. It is minus point. It was already there, but now it has changed because of this, some steps. It is divided by 2. Okay, what about b? Or b is basically minus 0.6375, but here in this equation b is plus, here is minus. I'll be replacing this by minus b. I'll replacing b with minus b. I didn't do that, that's why the answer was not right. So we have to replace b with minus b because we are having here f2, we are having minus f2. Okay, so let's press equal, and then we have to c, where c, you see that it is 4f3 here, whereas it was 2f3 here. So I'll be simply taking 2 multiplied by c. Okay, because you see I'm using what, instead of 2f3 I am using now 4f3. So if I multiply this with 2, I'll get 4f3, and then I press equal. So x is okay, 0.4. Now you see that we're getting exactly the same value, 0.74068. It means the value is repeated, so we don't need to do other step. If it was not repeated, you would have we will do this step again, right? It's because you'll be finding again y and again x, for 0.4 you'll be again finding f4, and then you will put the f4 in the formula to get y4 again. It's okay in this case. Yeah, if you want to improve the value, then the next value for y5 you'll be again doing the same steps as I've done in the first step. So I think it's clear to everybody now. I'm moving towards the MATLAB code for this method. Okay, so it's a straightforward MATLAB code. There is nothing difficult in it. Okay, I'm just labeling that with the Milne Simpson. I'll be inputting x now, y and my h as well, and f is the function defined. Okay, so what I'm doing, I'm just introducing n. N is the length of x minus 4. Why I'm subtracting minus 4? Because you'll be known y0, y1, y2 and y3. Okay, so for I is equal to 1 to n, what does it mean? I'll be starting from 1 to maybe 2 up to 2 and maybe up to 1 and so on. So we take yi plus 4, that means the predicted value of y4, which is y3, because see it is y4. Keeping in mind MATLAB is starting from 1, so I plus 4, that basically means y5, but y5 is basically what? That is y4 theoretically. This is, you see, is y1, but theoretically y1 means y0, the initial value. And then we have 4h by 3, 2 times x 1y1 minus f of x 2y2 plus 2 times f of x 3y3. This is the predictor formula. I may write this one here, predictor, and the next one is our corrector. Okay, so you see that in corrector, what do we have? We have y4. If I just simply call I to be 0, the initial value, so we'll be having y4, that is y2, and then we have h by 3 f of x 2 y2, 4 times f of x 3 y3, and so on. Okay, and then I'll just take the values from 5 till end, because it depends upon how many values of x you have given. Okay, and the initial values are known, so we don't need to find the to display the initial values as well. If you want to display that, you will simply say y, and then you don't need to do that. You'll just comment this one, so you'll be getting all the values of y, including the initial value, including the given value found by some other method. Okay, so how could you run this? You need to define x first. If you take the previous example, it was taken, we were interested to find the value at 0.4, so I'll just take this 0.4. Whereas my y values are, if you remember that from the table there, they are 1.90, you see 1, then 0.9097, 0.8375, and 0.7816. So I'll just take in these values, and then what I do, I'll just go for this formula, just to copy it from here. Yeah, I need to define function as well. So f is equal to @, I hope you understood that, and then we have two variables x comma y. Yeah, I should have used bracket, x y, and then we have the function is x minus y. Okay, I just input this one, and then we go for whatever we got there. So this is our y equals, and then we have to input the x defined, y is defined, h is 0.1. Okay, and then we have to give the f as well, so it will give the value of 0.747, which is exactly the same which we did a bit earlier. Right, if you increase the value of x, like we want to go to 0.5, so it will find the value at 0.5 as well. Okay, the rest is same, so we just go to code, and then we'll be having two values. You see, what index it is, 1. What does it mean? Yeah, I should have defined y again, because the y is updated, so we'll be defining y back. So right now, you see that now we are getting 0.7407 and then 0.7130. We have to give initially 4 values, not the 5th value. I hope it's clear to everybody. It's a very simple and straightforward method. I'll see you in the next method, which is Adams-Bashforth and then Adams-Moulton. Thank you very much.